Alright, NET-200 Introduction to Computers, 11/4/16. This is the end of week 10. We talked about decimal, base 10, 10 digits, and we talked about the placeholders. 10 to the 0, 1, 10 to the 1, 10, 10 to the second, 100, 10 to the third, 1,000. So we have two groups of 1,000, three groups of 100, five groups of 10, one group of 1. And if you went smaller, 1 over 10 to the first, that would be tenths. We got four groups of tenths, 1 over 10 to the second, hundredths, two groups of hundredths. So you can make a number infinitely small, infinitely large, using the number system we use. Computers use binaries, so they use digits 0 and 1, called a binary digit, or referred to as a bit. So the same system works. 2 to the 0 would be 1, because anything raised to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 times 2 times 2 is 8. 2 to the fourth would be 16. 32. 2 to the fifth is 32. 2 to the sixth is 64. 2 to the seventh is 128. And we typically work with excuse me, groups of bits as 8. 8 bits gives us a byte. But this is how we usually work with a byte of information. And then we convert those to base 10 so we can read items. Okay? So for example, if these 8 bits were configured, we have one group of 64, one group of 8, and one group of 1. That'd be 73. And so then we did some examples, like 111 would be 7, because it's, it's everything less than 8, as an example. You see that? It would be 31, 33. We took this number that we had written in the example, we'll see the example at the end, and we converted it to ones and zeros right here. And the way we did that, this is one group of 128, one group of 64, and 128 plus 64 is 192. And so we did it the same way, one group of 128, one group of 32, and so forth. Same thing here. To get 20, right? So we got one group of 16 and one group of 4. That would be 20. You see that right here, and so forth. All right, so here is the entire one converted. Okay, all of these match this number. So this is what the router really sees. It sees these ones and zeros. It doesn't see the dots either in there. It doesn't see those. It's just 32 bits. And the router looks at those. And so this is an address. And so when the router looks at the address, it wants to determine, the address has two parts. Okay, it wants to determine which part's the host, and in this case we'll show you why, but this is the host, and which part's the network, and this is the network part of the address. It does that using a mask and ANDing. So the mask we were using here, you can't see it completely there, was 255.255.255.0. So all these ones here represent 255, this represents 255, and this represents 255. If you added up 128, 64, etc., all the way down, if you add those all up, if you add those all up, you would get 255. And these are all zeros. And then we went through ANDing. ANDing is if you have a 1 and a 1, you get a 1. If you have a 1 and a 0, you get a 0. So when you take the mask and AND it with the address here, you get the network. You get the network part of the address. Okay, so a router can AND it. It can take an address, AND it with the mask, and get the network part. Then it's going to use the network part to look it up. Okay, now this right here, the mask, can also be represented as prefix bits. So we have 8, 8, 8, and 0. So the prefix bits would be these here. So that'd be 24. So you can use a prefix to indicate what part's the network and what part's the host. So prefix and mask, those would go together. The address can be a host, like we have here, or it could be just a network address. So I'm going to write the network address down for this. And that would be, see if we can see it here. That would be 192.168.20.0. So that this, I should just circle here, this would be the network, and this would be a 0 then. So I'll write it again over here. 192.168.20.0. That's actually the network address. We would not assign that to anything. That's the network. And a broadcast would be if the host part was all ones. We'll look more at that here in a minute. Okay, so this is just a repeat of what we had before. So in this case down here, when you AND it, you get this here. So the network part of this address would be 192.168.20.0. Okay, and the broadcast would be if you had all ones here. So that would be 192.168.20.255. All right. So the host, we either configure an interface with a host address or some device, a PC here in this example. And then we did some examples here. We looked up Dell. We mentioned the network part of this address that NIACC uses, right? This is the host. That's where the server is. 207.165.226 is a host. Comes in through the ICN. When it comes to, so when you come from home to get to the work server using this address, the internet's going to use the host part. When it gets inside our network, it uses the host. The internet will use the network part. Make sure I say, alright, the internet will use the network part through the routers, and then when it gets to NIACC, this host part will get it to the correct computer. Eventually putting the MAC address on it and getting it to the correct computer. Alright, so we looked up that. Here's an example. We wrote out the mask. Then we had another example, /30 in the lab work we were looking at. So that mask is 252. /30. 30 prefix bits. So there's 30 prefix bits, so they're all ones except for these last two over here. And we did an example. They retook Chapter 6 assessment. Chapter 7, we've been working on IP addressing. So we did an example. We had some PCs here. We gave a PC an address here. We talked about what part's the network, what part's the host. Then we had an example over here. This part's the network because of the 24. That part's the host. Okay, same thing over here. These two are on different networks because of the 10 here and the 20 here. They're two different networks. This would be, as an example, this would be the broadcast address for this network. And this would be the network address for this network. And then the router will route traffic, so if something leaves a PC here, needs to get to a PC, leaves a PC here, and needs to get to a PC over here, this router will look at the network part of the address and see that it belongs over here. This one will see it belongs here, and then right here it would put a MAC address on it and it would get to the correct computer. When it comes back, same thing would happen. It gets here, put a MAC address on it, and it will get to the correct computer. And the last thing we need to mention, the groups of private addressing. 192.168, private addressing. 10, all of these 10s are private addresses. And then this range of 172s, that range. So those are the private addresses. None of those can be used on the internet, and none of them are. You'll never see those being used within the internet. And that's it for today.